I'm going to introduce Stephen Mather, who is going to talk about, what do you put here is OSM Awesome Botnet Communications. And Stephen Mather is am I pronouncing that right?
Yeah.
Stephen Mather is trained in ecology, geology, and geography, but hangs out with IT professionals extensively and knows many computing languages and environments, if superficially. His career has wandered from academic pursuits in forest ecology to the fast-paced world of glacial ice velocity mapping, from spatial data infrastructure development to deep spatial analysis. He is currently a geographic information systems manager in the public sector and has been an observer and loudmouth, if somewhat uninformed, participant in NEOISF meetings for a couple of years. So as we all know, we're all geologists by heart. So I think what Steve fits in here perfectly.
So my last slide is actually the actual slide. Everything else is just an intro on geospatial versioned data sets. And see, hopefully it's clear. I don't know as much as I'd like about security, but I thought I'd give this a try. So, oh, good gracious. There we go. Okay, so my name's Steve Mather. I'm on Twitter at SMather. I'm a future straw hat hacker, and I've been thinking about, and really sort of at a cursory level, what are some of the hacking opportunities within data storage and version geospatial data sets. I'm hoping this won't be death by PowerPoint, but I don't make any guarantees. So if you fall asleep, I'm not gonna hit you with a stick. I'm trained as a geographer, geologist, and ecologist, blah, blah, blah. I work in local governance. I'm not going to tell you where I work, but we happen to have 22,000 acres of open space and a lot of picnic tables. Oh, I don't hit things with sticks because I'm not allowed. So I'll go through the basic structure is why would we look at this? I'll introduce you to the big cheese for those of you who don't know the big cheese. We'll talk a little bit about standards-based version geospatial data sets, which are a little bit different than OpenStreetMap, and then talk really briefly, one slide on what makes geographic data special, is from a storage of information that maybe shouldn't be there perspective. I've done geospatial stuff for about, about 12 years, 11, 12 years, and I've been coming to NEOISF for a couple of years and been thinking about, okay, where's the intersection of those two things, and what's interesting about the intersection of those two things.
Hey, Steve,
What's that?
could you give me a brief definition of what you mean by geospatial?
Yeah, so are you familiar with OpenStreetMap? No. Google Maps.
Sure.
Google Maps is geospatial. So essentially you have, it's basically geographic data that's stored and retrieved through one system or another. You can do analyses on it. What I'm going to talk about today is mostly the storage mechanism, really briefly about, how does it get stored, actually probably not even how it gets stored, but the fact that it gets stored and that we store the differences and that there are a bunch of people working on building out these data sets worldwide. And that there are certain opportunities and vulnerabilities to that because, OpenStreetMap. These are mostly stolen from this address. OpenStreetMap is a worldwide editable wiki-style map to replace, not so much to replace Google Maps, but to replace the data behind something like Google Maps. And then there are a whole lot of ways to render your own tiles like Google Maps in all sorts of ways that you want, drawing from those same data sets. And you can draw from those by grabbing the current snapshot of what's been edited by about, I can't remember what their user base is, but it's something astronomical in the hundreds of thousands of people making commits to OpenStreetMap. You can filter in a lot of ways. You can dump it into a PostgreSQL database. What's really cool about the things that have been done by OpenStreetMap is they change international instance response by being able to build out data sets that nobody else has in time periods that are inconceivable otherwise. So this is day one of a small tile in Haiti after the earthquakes. This is day two, after a week, 2 weeks, and so in a very short time period after the Haiti earthquake, the people who had the best maps of Haiti were not Southern Command U.S. military. They were not any of the folks doing normal incident response. It was a bunch of college students hacking away at archives and probably stealing data from places they shouldn't, and digitizing that and then pushing it out. And so the situation that occurred was Southern Command's, they're all down there with their BlackBerries with 1940s data, and folks with iPhones have better data and are walking around and actually know where they're going. And that quickly, Southern Command really wanted to have iPhones, but then the application started being pushed out to BlackBerry, and we've seen this repeat with incidents response at the international scale again and again. And the reason that it works is the same reasons that open source models work, in that if you connect enough people with marginally related interests, you get some really extraordinary things and an extraordinary amount of energy that goes into these projects. So what they did would have taken a heck of a lot of money and a few years to do, and they did it in 3 weeks. So they went from day 1 to day 28, and actually Haiti's far better mapped within OpenStreetMap than Cleveland is. Something I'd like to rectify, but haven't gotten to yet. It's currently released under Creative Commons license, which is pretty liberal. They're going to switch that to an open database license. So there's a little bit, the license is a little bit more focused towards data rather than creative uses, and it's a little less ambiguous as far as commercial uses, but it's still a very liberal license, and it's now being used by lots and lots of people. Google Maps now charges if you reach their usage limits, and that affects somewhere between 40 and 60% of commercial users of Google Maps, and there's a mass exodus from Google Maps right now. So Apple's using OpenStreetMap, although they're not following license restrictions. But to OpenStreetMap Foundation's credit, they were very courteous. They had a welcome Apple, and said thank you for using our infrastructure, thanks for using our data. By the way, the data you're using is kind of old, and attribution. So, Foursquare is now using OpenStreetMap. Apple, as well as help me out here. What's that? Geocaching.com, and they're pretty much anybody who has a lot of hits is definitely switching over. And I should say, OpenStreetMap doesn't provide a tiling service. They provide the data, but there are ways. They actually do have a small tiling service, but it doesn't necessarily scale for those kinds of uses. But they provide the data, and there's a bunch of mechanisms for them turning those into map tiles that can be scaled. And Mapbox is one of the commercial solutions for that, and they're all pretty cool. Now the question is OSM vulnerable to abuse? Yes, it is. There was a high-profile case earlier this year where a Google contractor was making really subtle changes to OpenStreetMap, like reversing street directions. Things that you wouldn't notice by just looking at the data. It's a bit of an embarrassment for Google. And of course, those contractors will never work for them again, blah, blah, blah. But now there are also some standards-based geospatial services that allow for editing and retrieval of data. These come out of, they're similar to the standards for the web standards, and there's a governing body for that, Open Geospatial Consortium, and they come out with a number of different standards-based ways to store and retrieve data. One of those is called Web Feature Services, and that's been extended in a sort of an unofficial way to do versioning. And this is where it starts to get interesting because, this is total aside, but some of that versioning is now handled on the back side by Git, which is kind of cool. And if you read, this is from the GeoServer website, which is one of the implementations of Web Feature Service. They say that directed acyclic graphs are cool. That's mostly their explanation for using Git. And I just thought, well, naturally, I mean, who doesn't think that? And there's some special problems with geospatial security, right? So authentication is pretty much the same, but authorization is a little bit weirder because the layers are different than in your standard table. We've got different service types. So I talked about web feature service, but there are also web map services where you serve back, for example, a tile. There's per layer. So Bob can access this layer. Martha can't access this layer, but can access these other layers that Bob can't, which those are pretty typical. And then there's geography-driven authorization, where, for example, I'm only allowed to see data in Ohio, but I'm trying to retrieve data from West Virginia. And that's where some of the subtleties in authorization mean that any robust system that handles authentication, well, it handles the authorization side of things, really needs to understand the geographic context and can't just be a proxy placed in front. So, for example, if you go through the chain of how you would do authentication and authorization, you'd have an authentication filter, a service filter, then within whatever service you're working with, you might actually then have specific geography that says you can or cannot access information within that. And you can go deeper, you can say, I will only paint this for you in purple, not in yellow. You're not allowed to view it in yellow. You know, it gets pretty fine-grained. So yeah, where can we stuff some nefarious data? These tend to be large data sets, so there's a lot of room for hiding stuff within them. OpenStreetMap's about 250 gigabytes of data. The OSM diffs are much larger. And just to give you a sense of it, and this is a good example. I'm guessing this is in Germany. This is 6 or 7 years of OpenStreetMap digitization. This is essentially showing the changes over time for one particular city. So there's a lot of changes that happen. There's a lot of changes to keep track of, and there's a lot of users making those changes. I should go down here and see the dates here. And total aside, but there's a joke that if you want to get good OpenStreetMap work done in your country, import the Germans. They love OpenStreetMap. It's extremely popular in Germany and Europe in general. US has some catching up to do, but with a lot of high-end players looking for the data, I think that'll happen. So you can see that there's a lot of space to you have space in the export. You have X and Y coordinates in which to place things. So this isn't just some text that you're tweeting out with a Twitter bot. You can encode things within X and Y. You can encode things within Z, whether that be layers or whether that be time. So there could be 4 or 5 dimensions that things could be encrypted within this. You can store it in the differences. You can store it in the differences over a particular scope of geography, and then you can also store things in the differences through time. Now I'll ask this, and the camera's on, so maybe the genie's out of the bottle. So Mike, I guess this is as far as I've gotten with this. This is sort of as far as I've gotten with thinking this through. But I wanted to I was thinking I would come up with some scripts that would do this, and Spiral in a few months I'd do a presentation. But I thought I'd bring it sort of at the beginning stages to say, is this interesting, and how exactly would you guys think about this problem, and where would you go from here? Thinking about these large multi-dimensional data sets that are being edited by hundreds of thousands of users over the whole world, and have these potential vulnerabilities. Yeah.
Is there a way? My thought would be something along the lines of reputational scale, where people that are trusted, can have more say, and even having something where a difference isn't actually committed to the master data set or to the pristine data set until there are 3 different or X number of different people that collaborate on it.
Sort of like the decoding of words and
the captures.
Yeah, captures.
So once you get enough folks that
agree
say
on
this is this,
change.
Yeah. Now you could have a case of if you have based on reputational score, also someone gets to the point where you trust them enough.
Yeah. Where they can just apply diffs. Yeah.
Which that's actually similar to what MapMaker's doing, the Google branch of we're going to let you edit our
Which
maps.
drives me crazy, frankly, but go ahead.
But yeah, but one of the problems with that model specifically is even if you get, this is more not from the storing bad data, but information.
Yeah.
They don't really, and we all know this about Google, they don't really like to delete things, right? So even on their maps, once you get something removed, if you go to Map Maker, all of the deleted objects are still there. You can say, oh, no, open this one back up. And you can browse the edit history. So even if, like, you know, for whatever reason, if you've got a hidden company location or something and someone labels it on the map and you get approval to remove it, it might still be there in the Map Maker view when you search for it.
Okay, can you turn the camera on for a second? So the question was, how does data get committed to the how does data get committed to data sets? I haven't looked deep into OSM yet, but I know about WFS, and you know, once you're authenticated and authorized, you basically push XML back to the server, which then gets translated into whatever the backend, however it's stored on the back end. It's obviously something very similar for OSM. OSM is also a modified XML. It might even be stored in XML on the backside. I'm not sure. When I looked at the OSM documents, when they started out, it was a relatively naive process that built extraordinary infrastructure. And I say naive in the sense that it's not what any geospatial professional would have done, but it works, and it works brilliantly. And so I haven't gotten deep into, but there's a few different hooks into that system. So there's a few different front-end applications. There are some batch front ends, and so that's one thing I need to get deeper into exploring. And my idea would be to first play with this in a sort of isolated playground, which is why I looked into WFS first. The server I set up, play with it, hack it, figure out how this would work, and then go and talk to OpenStreetMap folks and get deeper into how exactly their system works. But I think the basic concepts of this is at least 3-dimensional, probably 4-dimensional. We've got diffs to store, and we've got time to store, and we've got space to store, and there's a lot of opportunity for storage. So then, what are their specific vulnerabilities in that context?
So maybe something as simple as, you know, using it to pass a message. You submit a defective update in a certain format, and then whoever you want to pass the message to looks at the history and sees the defective format, and nobody knows it, but it's totally untraceable.
And it could be arbitrarily small, so it could be visually, untraceable. So then, okay, what would you need to look at in those diffs to start detecting anything like that taking place? Yeah.
Well, if it's XML, can't you just have a comment out section that the computer won't read?
Oh, that's a good question. I don't know enough about their specific infrastructure, but potentially, yeah. Yeah, you can pass it directly. Yeah.
So does it let me submit something for like Canada, Australia, or something halfway around the world when I live in Cleveland? So can I draw maps in Antarctica and the North Pole?
Yep.
Well, but at the same time, I may go to a trip in Europe.
Yep.
You know, I'm a geek, so I want to spend my time going around there mapping out whatever. I come home to my trusty internet connection, upload it.
Yeah, and you should be able to do that. I mean, almost nobody was in Haiti when they were first doing the Haiti digitization, and that would have been a problem, you know. And there were, there's more to that story as far as reading SMS feeds and other things, but as far as building the basic data sets, it was old maps and aerial imagery and students all over the U.S. So it would be difficult to do, whitelisting or gray listing based on geography. Although it might be it could be one of the weighting factors in securing it. So as far as that trust element, but you do run you have right now. I mean, I talk about college students in the U.S., but you've essentially got a worldwide network of volunteers updating and fixing data in these data sets for just to update them, and also for incidents response. They could be in Nairobi and Berlin and San Francisco and Singapore all at the same time, and they're all legitimate. So it's kind of a wacky thing. Yeah.
Won't you get to the part where it gets populated enough that the changes would be on a small scale?
Yeah, and for large swaths of Europe, that's where it's at.
Because that would be probably the test bed to try to figure out how to stop the people that making bad changes and stuff.
To sort of say,
'Cause
okay, this is,
you could have some type of statistical analysis.
see if it makes sense that there are changes taking place. Yeah, yeah.
Just not being really familiar with what you're doing, but would it be possible to extract the geolocation information for the EXIF metadata to cross-validate that the coordinate they're trying to assign the data to is in fact, embedded in the data itself?
I mean, typically how the edits take place, I mean, a lot of the edits take place through the graphical front end, where you're essentially just changing the again, I don't know enough about their infrastructure. I guess that's the short answer. But typically they're either batch changed or batch additions, which is unusual, or people will have OpenStreetMap parties where you basically have an event where you're doing the updates for a particular region. So these are the sort of non-crisis responses. And I lost my train of thought. What was your question?
My question was if people are submitting image data.
The imagery typically is actually, so OpenStreetMap's gotten a lot of support from Microsoft is providing part of the backbone for it. MapQuest is also, which is kind of fascinating and kind of cool. And I believe Yahoo has also provided some input, and Google has actually provided some code monies. But from an imagery standpoint, I think they're pulling from MapQuest, Yahoo, and Microsoft, and that imagery is actually typically whatever they're providing as a general product. Now there is some validation which happens, because one of the important things about the licensing and legality of this is a vouchering process. So some people are careful as to go out and take pictures of a given street sign before changing it in OSM, in order to ensure that no one can say that that was read off of a Google map and then populated or whatever other source. And then some of the data is also collected through GPS traces naturally, especially for alignment of roads and such. So.
Sure. I guess what I was thinking is that some of your smartphones, smart cameras, whatever, will insert geolocation coordinates
in the EXIF, yeah.
Yeah, in the metadata of the image. And if somebody's submitting that image as a particular location, they can at least be cross-validated.
Yeah.
The coordinates are close, if not on.
To sort of create a voucher system.
Saying it came from. Not that you can't change it, but.
Right. But it's at least another check.
Yeah.
Yeah. Cool. Well, thanks, guys. This is like the shortest NEOISF ever.